Everyone, so now I'm going to prove proof number 3.3, which we want to show that the norm can serve as a sublinear functional. So first we want to show that any generic norm works. So if we just, define our sublinear functional to be equal to the norm of x, x1 plus x2 is equal to this, which by the triangle inequality is less than or equal to x1, the norm of, plus the norm of x2, which is defined as p of x1 plus p of x2. And for any positive alpha, we have that p of alpha x is equal to this, which is equal to the absolute value of a times the norm of x, but since a is positive, the absolute value is just equal to alpha, and then we have that. So we've shown that it's a sublinear functional. Now we want to show that if we have a bounded linear functional on some subspace M that has its norm, f, well, that's the norm. We want to show that we can extend it to f, and that the big F, and that this extension using the Hahn-Banach theorem, it's going to produce the same norm as what the little f has when we're only evaluating it on the subspace M. So we start off by noting, here's one definition of the norm. Alternatively, the norm is also the sup over all of these. So we know that for any x that isn't the zero vector, this is going to hold. The norm of little f has to be greater than or equal to the absolute value of f of x, the absolute divided by the norm of x. So this means that for any x in our subspace M, this relation holds. And let big F be the Hahn-Banach extension of little f to all of x. And so since we've kind of let this be equal to our sublinear functional p of x, we have that f of x needs to be less than or equal to that for all of the x's. On x defined for any x, not just the M subspace. And so we know that the norm of big F is going to have to be less than or equal to the norm of little f. But of course, we also know that when we're looking at the M subspace, which is also a subspace of x, and so if an M is an element of x as well, then we have that if we look at the sup over just those elements in M, we're going to get this, which we already know is equal to that norm. And so we have shown here that the norm of our Hahn-Banach extension f has to be equal to the norm of our little f.